Okay, right now in question 9, they say that a metal frame is built to help provide some shade to a triangular piece of land ABC. A, B, C are on the same horizontal plane. AC equals to 7 meters, CB equals to 8 meters, and AB equals to 10 meters. AF and AF, BG, and CH are vertical metal poles. And then they say that AF, right, AF equals to BG, which is equals to 3 meters, and CF equals to 2 meters. HF, FG, and GH are metal poles that complete the metal frame. Now, in the question, if they are telling us that AF ne FG, if they are saying that what is it? Where is the metal poles? So we are told that HC ne wait, they telling us that HF ne HF, FG, and GH ne metal poles that complete the metal frame. All right, because AF, okay, yeah, there it is. Because AF, BG, and CH are vital metal poles. Now, if they are telling us that those are vital poles, basically I can just say that there's actually a 90-degree angle there. There's actually a 90-degree angle there, and there's also a 90-degree angle there as well, actually. All right. And then they're telling us that in question A, they say that calculate the area of triangle FGH. So we actually gonna have to calculate the area of triangle FGH. So we are actually dealing with that triangle over there. So we need to calculate that area of that triangle over there. All right. So just understand it. Now, for us to actually calculate the area of that triangle over there, ne, we are actually gonna need to use something called an area rule, right? Now, to use an area rule, ne, we gotta either know what is the side of FH and the side of HG and the side of FG. But for now, can you actually see that looking at the figure AFGB, that is actually a rectangle? So basically, we can see, because can you see that AF equals to 3 centimeters, and then GB is also equals to 3 centimeters, and of course all of those angles are 90 degrees. So we can just say that for now, that length of FG lying on the triangle FGH is actually 10 meters. All right, so we basically gonna need to find that side there and that side there, and then maybe find that angle over here, or we might need to find that angle over here, we may need to find that angle over there. And for us to find that angle, we're gonna need to have two more sides, because we have this side, so we're gonna basically need those sides over there. Then from there onwards, it's gonna be easier for either using the sine rule or the cosine rule to actually find the angle between, and then actually using the area rule. Now, for us to be able to find the length of FH or the length of HG, it's gonna be kind of tricky, but the only way that you can actually do it is to construct. You're gonna need to construct length HA or length AH, right? So you're gonna construct a length of AH, right? And also a length of HB. So you also want to construct a length of HB, right? So I'm gonna write the construction, right? So I'm gonna write construction, draw line, draw line HA, draw line draw line AH, and line HB. So you gotta draw line AH or line BH or line HB, I mean to say. All right. So you gotta have to draw the line of AH and line HB, and then from there onwards we're gonna actually try to calculate those lengths over there, that AH and that length of HB. Alright, and then now to actually do that we're gonna work in those triangles. So I'm gonna say in triangle AHC, right? Triangle AHC. So find the length of AH. I'm gonna say AH squared equals to AC squared plus HC squared. Then it's gonna be theorem of Pythagoras. Theorem of Pythagoras, right? Then we're gonna have an AC which is given as 7 squared plus HC which is 2 squared. Right now to find AH squared, we're just gonna square root both sides. I mean to say square root both sides, and then basically if you say 7 squared plus 2 squared, it's gonna basically give you 53. So basically AH is gonna be equals to square root 53 meters, right? So then so far we found that AH is actually square root, we just found that that length is square root 53. All right, then changing a different color, I'm gonna say in triangle HCP, in triangle AHBC. So it's gonna be HBC. So find the length of HB. I'm gonna say HB squared equals to HC squared plus BC squared, right? So it's gonna be plus BC squared. Then it's also theorem of Pythagoras. All right, then it's gonna be HB squared, which is equals to HC is 2 centimeters squared plus BC squared is 8 centimeters squared. All right, then we're gonna say HB squared square root of that, right? So we're gonna take the square root of that and the square root of that sum over there. So we're gonna say 2 squared plus 8 squared is gonna actually give me square root 68. So actually HB is actually going to be square root 68 meters, right? So I'm gonna go put square root 68. So that length over there, it's square root 68. All right, and then now what we gonna do now, can you see that now if you look at triangle HBG, can you see that we have a length there and we have a length there? So basically we need that angle over there. And also as well, can you see that for triangle HAF we have a length here and that length there, and we basically need that angle. Now to find that angle there, that angle there is actually equals to that angle over there, and then also here that angle over there is actually equals to that angle over there um because of alternative angles basically. Or for you to prove it, remember that this line there, that angle there is 90 degrees. So for you to find that angle over there, you're basically gonna use your trigonometric ratios, then you're just gonna subtract 90 and you're gonna get your angle. So that's why I'm saying that that angle there is the same as that one over there, because remember it's a 90 degree there and also it's a 90 degree there. So for you, remember, if you wanted to find that angle over there, which is this one, you're gonna say shift of 10 2 over 7 basically. That's what you would have done. And then after finding that angle, you were going to say 90 minus that angle, and you were going to get that angle. So that's why I'm saying that angle is equals to that one, and then that one is equals to basically that one over there. Okay, now to find those angles there, we're gonna still work in the same triangle. So let me, for the purple one, we're still in angle. So I'm gonna say that angle GBH, angle GBH, right, is equals to angle BHC. Right? Then I'm gonna say angles, alternate angles. Then you can just see that those lines are basically parallel to each other, right? And now remember, for me to find angle BHC, I'm gonna have to say 10 of angle BHC, which is gonna be equals to angle BHC, which is basically gonna be just 8 over 2. So I'm gonna just say BHC is gonna be just shift of 10 4 basically. All right, and then so now I can just say that that angle, therefore that angle G B GBH, GBH is basically shift of 10 4. So I can just put that over here. So that is just 10 minus 1 4. Okay, now going to the green one, can you see also that I told you that angle FAH, angle FAH is gonna be equals to AHC, right? And also it's gonna be alternate angles. Then I'm gonna just say because of AF being parallel to HC. All right. Then now I'm gonna actually go and do this. So I'm gonna say 10 of angle AHC, 10 of angle AHC is equals to 7 over 2, right? And then basically AHC is equals to shift of 10 minus 1 over 7 over 2. So basically now I know that that angle over there is just 10 minus 1 7 over 2. Okay, so now I know all of those angles and I know those sides. So I know this angle here and I know that side and I know that side. So for me to find HG, I'm gonna basically use the cosine rule as same for the triangle of AFH, because I have that angle there, I have this side and I have that side. So for me to find the side, I'm gonna use a cosine rule or cos. Then I'm gonna shift and use blue. So now I'm gonna say in triangle AFH, in triangle AFH, to find the side FH, FH squared is going to be equals to AF squared plus AH squared minus 2 times AF dot AH and cos of angle. Remember, and cos of angle A and cos of angle FAH. Yes, cos of angle FAH. Right. So I'm basically gonna say, now remember, FA squared is AF squared. It's 3 squared, and that's gonna be square root of 53 squared. Then it's gonna be minus 2 times 3 multiplied by square root 15, and cos of, remember, FAH is actually the same answer there, so I'm gonna just say FAH. Okay, then switching to a different color, cos of 10 minus 1 2. Okay, then now to find FH squared, just to find FH, I can just square that whole entire thing there. So it's gonna be basically 9, sorry, I think if you do 3 squared plus square root 53 squared, you're gonna get 62. So it's gonna be, sorry, so it's gonna be square root, right, of 62 minus 6 square root 53 minus 6 square root 53, and then cos of 10 shift 7 over 2. Then basically your FH is going to be square root 62 minus 6 square root 53 and cos of shift 10 7 over 2. And if you do that, you're going to basically get an answer which is going to be square root 50. All right, and then now working in triangle, what HGB ne? Now in triangle HGB, right? Now in triangle HGB, to find HG squared, it's gonna be equals to GB squared plus HB squared minus 2 times HB cos of angle GBH, right? Cos of angle GBH. All right, then I'm gonna say equals to. All right, are you going along with me? Then now remember, GB squared is actually 3 squared, so that's 3 squared plus HB squared. HB squared, remember, is going to be square root 68, so that's square root, so that is square root 68 squared minus 2 times 3 multiplied by square root 68 cos of shift 10 4. Okay, so that is shift of 10 4. That means that HG squared, I can put that in a root, right? Then it's gonna be, okay, so if you say 3 squared plus that squared, it's gonna be 77, right? Then it's gonna be minus 6 times square root 68 cos of shift 10 4. All right, then basically HG should be equals to, so it's going to be 77 minus 6 square root 68 cos of shift 10 4. and that's I get square root 65. So that is square root 65 meters, and then remember here is also meters. So now I can go and put that Hg is actually, remember we found that FH, right? FH is square root 50. So that is square root 50, right? And that is square root 65. Okay, so we found that that is good. So now what we're gonna need to do, seeing that I'm running out of space, I'm gonna now say that in triangle, now I'm gonna say in triangle HFG, right? Now I'm working in triangle HFG. Now I'm gonna need to find the angle between those two lengths there. Now to find the angle between those two lengths there, I'm gonna say that FG squared, I'm gonna still use the cosine rule. So I'm gonna say FG squared equals to HF squared plus HG squared minus 2 times HF minus H plus times multiplied by HG, and then cos of angle FHG. I mean to say FHG. FHG. Right now, remember we found that we know that FG is actually 10, so it's going to be 10 squared there. HF squared, HF or FH is going to be square root 50. That's going to be square root 50 squared plus square root 65 squared minus 2 times square root 50 multiplied by square root 65 cos of FHG. Alright, and then you can basically rearrange that formula. So now if you do rearrange the formula, you're gonna just have cos of FHG equals to I'm actually having a smaller space here, so let me just take it just here, yeah, just here. So I'm gonna say cos of just here, cos of FHG is gonna be equals to so it's gonna be equals to 50 plus 65 minus 100 all over divided by 2 times square root 50 multiplied by square root 65. Alright, square root 65. So basically if you simplify all of that, right, if you do simplify all of that, basically it will be 50 plus 65 minus 100, then 2 times square root 50 multiplied by square root 65, which is just I get 0.131558729. Now to find that angle, I'm gonna just say shift of cos of all of that. Okay, I hope you're going along with me, right? And then basically if you do all of that, so I'm gonna say shift of cos 0.131558729, and I get 82. I get 82.440326 692 degrees. So now I've actually calculated that angle. Now let me use a different color. Now using a different color to actually now calculate that area. So I'm gonna now say area of triangle, right? Which triangle? FGH. Area of triangle FGH is basically gonna be a half of that F, a half of HF. I'm sorry, a half of FH multiplied by GH and sine of angle FHG. Right, and then we're gonna say, sorry, then we're gonna say a half. Now FH, we know that FH is actually square root 50, and GH we know that is square root 65, and then it's gonna be sine of 82.44032 degrees. Then we're gonna say equals to, right? So it's square root 50 multiplied by square root 65, then sine of 82.44032 and then basically you should get an answer which is gonna be rounding off to 2 decimal places, which is gonna be 28.3 meters squared. Okay, right. I know this was kind of like a bulky question, but yeah, the best trick for it was to use to actually construct was to actually do a construction, I mean to say, of drawing line AH and line HP, and then from there onwards it was applying cosine rule all over the place until you got your answers. Okay, I hope that's understandable.